Okay guys, today we're going to look at 9.2.3, language required for software solutions. So the use of EBNF and railroad diagrams to explain the syntax of different languages. Here's what the hell is going on. How do I learn a language, or how could I understand a language, or how do I begin to problem solve if I haven't worked out the rules of the language just yet? How am I able to say, hey, this is how I write this in this language, if I don't really know the language? As a programmer, there's a series of languages that are in my repertoire, right? There's things that I know and I really love. How do I pick up other languages? If I post on a forum like Stack Overflow, how do I respond in syntax to the person when they're like, oh, this statement isn't working in JavaScript, so do I respond in JavaScript? Wouldn't it be really helpful if I had a universal language? Kind of like pseudocode is universal for logic, but a universal language for explaining the syntax or the rules of the language. Okay? There is two different global ways to explain syntax rules in any particular programming language. This is the same, and I can use these to explain the syntax of any language whatsoever. It's like a global language for languages. It's called EBNF and railroad diagrams, and that's what we're going to look at today. So if we start, we refer to EBNF and railroad diagrams as metalanguages. So that prefix meta means inside of. So metalanguages are kind of like languages for explaining languages. Yeah, that's what that word meta means. So they're tools to explain the syntax rules of any particular language that I'm implementing, in whatever system I'm designing. They use universal symbols, literally symbols, I was going to say diagrams, but literally universal symbols. So no matter what language I'm trying to explain, if I know EBNF and I know what the symbols mean, and someone says, hey, this is how you write this in JavaScript, but they show me in EBNF, I don't have to know JavaScript. I can immediately understand it. Okay? So, what does this look like for HSC questions? I'm going to show you some questions before we start, just so you guys can get a bit of a grasp of, what kind of questions they could ask. So, a system requires a user to enter a valid ID, which must start with an N or an E, and the following instructions are displayed. It first has to have an N or an E, then it must have a hash, followed by a code, then another hash. The code must start with 2 or 3 letters, followed by at least 2 digits. Okay? And then I have these weird things, A, B, C, D, and E. I have these weird EBNF definitions down here. I haven't learnt what EBNF is, and I don't know what any of these symbols mean, but I can assume that one of these answers is the correct way, or the correct syntax rules for this language for a valid ID. Okay, these are the types of questions that we're going to get, and we'll come back to these questions once we've gone through EBNF. Okay, this weird diagram is a railroad diagram, and some of the time I will get asked to translate between a railroad diagram and an EBNF. So this question was, here's some instructions or some rules. How do I represent those syntax rules in a language? Here's this other thing, which is a railroad diagram, which is another universal tool. To be really honest, I really don't like railroad diagrams, but whatever, you just have to go with it. And it's a graphical form, or like a drawing form of of metalanguage. I'm sometimes asked to translate between that and EBNF, and it says, okay, this diagram and this logic here, which we'll go through as well, which is its EBNF equivalent? And again, here's another railroad diagram. What's its EBNF equivalent? Okay, and we're going to come back to these questions. So, the two types of metalanguages, EBNF, which is a text-based description of syntax. So you'll notice those A, B, C, and D of that first question A, B, C, and A, B, C, and D, sorry, of that first question, it was like text-based with weird brackets and weird equal signs. Or railroad diagrams, which were those weird curly lines and circles, brackety things. Yeah? So there's two different meta-languages, text-based or graphics-based. Text-based is EBNF. Railroad diagrams are a graphical base. Okay? These two slides, this one here and this one here, I would 150% print onto a flashcard because you have to know these brackets. You have to know these symbols. In EBNF, you have to know these symbols. If there is a line between something, it is a choice. If there is a greater than or less than encapsulating something, that means you have to have that thing. Yeah, it's a terminal symbol. If you have, non-terminal symbol. If you have squiggly brackets, yeah, squiggly brackets, that means whatever's in the brackets can be repeated. Yeah? If you have these square brackets, that means optional. And just normal brackets groups things together. You have to know the difference, particularly the difference between curly and straight brackets is going to become really important, guys. Really, really, really important. Particularly when you're trying to interpret EBNF. In railroad, yeah, so the equivalent, so this non-terminal symbol in EBNF with greater than and less than, and we'll have a look at what this actually means, non-terminal symbols. Its equivalent in railroad is something that is in a rectangle, yeah. A terminal symbol means you have to go through it, yeah, you must go through it, is in a circle, and then just the path lines is the logic that it follows, okay? And we'll go through lots of examples of this. Okay, so what you often get is, something with multiple layers. So if you have a look here, it wants to work out which one of these sums follows the syntax rules or is legal or illegal. And if we look up here, it says sum equals, a repetition of numbers minus a repetition of other numbers. I don't know what number means in sum. I have no idea what number means. So in this EBNF statement, it also tells me what number means. It says a number is a digit multiplied by a digit. That's a number. So a number can be a digit multiplied by a digit. But then in terms of number, what is a digit? And you'll see it's kind of like an onion. It has layers, yeah? A digit is either 1, and this is where the symbols are really important, or, because remember that's what this symbol means, 1 or 2 or 3. Okay, so let's follow this. A digit can be 1 or 2 or 3. Okay, it can't be anything else. A number is a digit multiplied by a digit. So within here, it's a digit multiplied by a digit. Which of the following statements works? Now, one of these statements I can immediately eliminate, okay, and it is B. The reason why I know I can immediately eliminate B is a digit can only be 1 or 2 or 3, and B has 4 in it. So B's out. Okay, now number, so within the brackets here, a number has to be a digit multiplied by another digit. I notice in C here, this first bit, 1 multiplied by 2 works because 1 and 2 are digits and there's a multiplication between them, so that's cool. That works. Yeah. There's a minus, so that works. Yep, so far digit, minus, yep, we're cool so far. This, I have a plus symbol in between here, which means that this statement here is illegal. So C and B are illegal. The only one, let's check and see if it works. 1 multiplied by 2, 1, 2, yep, that works. Minus, yep, minus. 2 multiplied by 3, yep, that works as well. Okay, so A works, it's legal. B and C are illegal. Okay, here's the railroad diagrams. Okay. How many have I got? Oh, let's go back. That's how many I have. Okay, so here's the railroad diagrams. What we do is, it's called a railroad diagram because I follow it around, right? I follow it around. A string. This is a railroad diagram for a string. I go through here and it goes letter, okay? And now I follow the path like a train. A train cannot come back and go backwards, so the train always has to go forward. So it can't get to this point and reverse and go around. So the path actually through here is this. Now once it gets to this point here, it can go up or it can go down. It also can go straight on through. Okay, can also go straight on through. Here's where it's really important to remember symbols. Okay, so there's a couple of things that I can immediately eliminate. This says it's a terminal symbol. This means it must go through this, and you'll notice it ends with a dollar sign. Okay, so identify which of the statements are illegal and illegal. Immediately off the bat, before I look at anything, I can eliminate two of these because C and D do not end with a dollar sign, so they cannot be right. Okay, so that leaves me with A and B and C. Let's have a look here. A string must start with a letter. Does A start with a letter? Nope, starts with a number, so A's out as well. So my only two things I have left are B and E. Okay, so let's check and see if B works. String A, which is a letter, yep, that works. I go all the way through here. I am actually able to come out the other side with a dollar sign, so B works. Now E looks very different from B, but let's see if it works. Okay, so it says A, C, 11, 11, 1, 1, B, C, dollar sign. So it can go along here. It can go up for a letter A, goes along here, that's the first A. Goes up here, that's the second A. That's a third A. That's C, yep, that's working so far. 1, yep, that works. 1, that works. You'll notice I could have gone up. I went up for a number of times, and then on a time down, I can go back down the other way. 1, 1, B, C, dollar sign. Yep, that works fine. So B and E work. The thing that you have to learn here, guys, is that you can go up or you can go down. Yep, but you can't do both of them at the same time, obviously. Or you can go straight through. Okay. So this is what I mean by oniony. Okay, so the declaration for an array is array name followed by the index. Okay, so array equals array name followed by the index. The array name equals a repetition of letters. What's a letter? A letter, and so that's why it has to give me letter, is A or B or C. Now this ... or Z means that you can assume in between there is the rest of the alphabet. So if I can have a repetition of letters, that's how I'm able to spell, array, like element, E-L-E-M-E-N-T, E-L-E-M-E-N-T, repetition of letters, yeah. Index is a digit, a repetition of digits, and a digit is either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Sometimes it's hard to obviously, and I don't have enough space to write out everything, so we can write ... and assume, obviously, the numbers that are in between. Okay. Now, dogs, brackets, 10. Dogs, brackets, 10. Cat, optional brackets 1, or trees, brackets, index. Okay, let's go back and see why they would be correct. Why they would be incorrect. Okay, why would be incorrect? Now this last one, trees, brackets, index, is really obvious because index is not a digit. yeah? And if we go back here, a digit, it had to be a number, yeah? And obviously index is not. Cats with this bracket 1 is incorrect, yeah? Because that's the wrong type of brackets. This is the trickiest one because dogs brackets 10 looks 100% correct. But when I look a little bit more closely, guys, you'll notice this has a capital D for dogs. And if I go back, all the letters are in lowercase. So those are actually contravening the logic rules for that language, okay? So that's going through a couple of examples for you. Let's go back and have a look at these examples that we looked at first off. Okay, we'll start at the end. Okay, move me. Which of the following EBNF statements is a correct representation? They all say move me and they all go through move. Okay, so that's pretty obvious. We have to work out which one of these is correct. Okay, so when I go along here, okay, I do have, actually, I'm going to change my mind midway through. I'm actually going to go back to the start because there's a reason I put these in order, because this question actually leads to that question. So ignore me for a moment. When we're looking at EBNF, yep, we first have N or E. So then it's followed by a hash and a hash. These all have N and E followed by a hash and a hash. What do we notice though about the brackets in A and B? The brackets in A and B are square, which means optional elements. You first must start with, it says you must start with an N or an E. So A and B are immediately out. C and D have just enclosed N or E. Yep, so that's what we're after. Even though all of these have the or between the N and the E, these square brackets here made that optional. So we have to get rid of A and B. So it's either this one or this one. And then it says a hash followed by a code, then another hash. Okie dokie. So they're both following the same thing. Their code line says a letter part and a number part. They're both exactly the same. Here's where we have to decide. C has a letter, squiggly brackets, another letter, whereas D has letter, optional letter. Let's go and look at the logic. The code must start with 2 or 3 letters. So these both have 2 letters. This one gives the option to repeat more letters. This one gives the option to repeat letters. This one gives the option for another letter. This is looking a little bit more like my logic, yeah? Because technically with C, I could keep on repeating. It is the equivalent of this, repeating in a railroad diagram. So I'm pretty confident that it's D, but let's just keep on confirming. Then, so it's 2 or 3 letters, no more, followed by at least 2 digits. So they both have at least 2 digits. That one gives me the option for a third. This one allows me to repeat for a third. So D is definitely the answer. 2 letters or 3, so the option for 3, and at least 2 digits. So digit, and the option to keep repeating. Okay, so this railroad diagram. Which railroad diagram is equivalent? Okay, so I go along here. I have the option to repeat this. So this is a repetition. This is the equivalent of my curly brackets. Okay, so these all start with the curly brackets because this is my option to repeat. Okay, when I'm going along the path of the train, because it's a railroad diagram, what do I hit first? I hit and encounter 5. Okay, so that immediately eliminates B and D because they both start with X. So it's 5 and then X to be repeated. So it's either A or C, and I come up. Now, this guy here gives me the option. This is my optional. I can go down for 5 or I can go through for M. Okay, so B, what did I say? A or C, sorry, A or C are currently, because they both started with 5, they both give me the same thing, M or 5, which is what this is saying here. I then come through here. I have to go through 5. I have to go through 5 and then I can go out. But I can also go through 5 and then repeat up again and go through 5 and repeat up again and go through 5 and repeat up again and go through 5 and then go out. Okay, so between A and C, I have to go through 5. So 5 has to be outside of any kind of bracket or repetition, and then I can keep on repeating. For C, it only has it in a repetition, but because a circle is a terminal symbol, I have to go through it if it's on a pathway where a path line that I go through. So my answer for this is A. And this is the reason, team, that I wanted to show you that railroad diagram before going to this one. So move me, I can go through and I can just do move, and that's fine. That's why it's the only thing sitting outside of any particular type of brackets. But I do have the option to repeat. So I do have my curly brackets repetition, and I hit through what first? I hit through angle. So move is definitely there. I hit through angle and then length. Yep. So angle and then length, angle and then length, which means these two are down, C and D are out. Angle, then length. The only difference between A and B is my brackets. This one here means optional. This one here means repeat. Which one am I picking? I hope you get by now that I'm picking the repeat one. Okay, team? And that's it. That's EBNF and railroad diagrams.